In this video, we're going to try and find a way to describe a plane in 3D space. So suppose you have two non-parallel vectors. Whenever you have two non-parallel vectors, you're always going to create yourself a plane. So we're going to try and find a way to describe this plane. Now let's look at a simple case in 2D. Let's look at the line y equals 2x plus 1. So if you look at a general point, let's say p, x, y here. If you look at this point here where it's 1, 2, 3, 4 across and then 2 up, you would put this into here. So because this is your x, this is your y. Put this into here. That would be 8 plus this would be 9. So overall it would be 9. If you put this into here, it would be 2. So this side does not equal this side. Therefore, this point here is bad. Therefore, this point here is bad. If you look at this point here, it would be bad. If you look at this point here, it would be bad because the left-hand side won't satisfy the right-hand side won't satisfy the left-hand side, so it would be bad. But then if you look at this point, if you look at this point here where it's 1 across, and 3 up, if you put this into here, so this would be, well, this whole thing here would be 3, and then put this into this thing here would be 3. So the left hand side equals the right hand side. Therefore, this point is good. So if you look at this point would be good. This point here 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 would be bad, bad, bad. So normally you would look at a general point P, x, y, and then you would set up a condition. If this condition where the left hand side is the same as where the right hand side is the same as the left hand side, then eventually you're going to obtain all the points which will be good. Eventually it will draw out your straight line. So now going back into 3D, if you select a general point, just like we selected a general point over here, if you select a general point, let's say this point here is here, this general point here. If you select this point, before we proceed, let me just remind you of something. So remember, if you have 3 vectors, 1, 2, 3, if you compute the determinant of those 3 vectors, this thing here, the determinant, will represent the volume. If you have 3 vectors that lie on a plane, then the volume will be 0. So going back to here, if you have a general point here, and then work out the determinant of those three vectors. So the first vector would be from 1 to our general point. So that's this. Notice that this is blank here. This is 2. This is 3. So our first vector would be from 1 to our general point here. So that's this vector here, and then this vector is from 1 to 2, from 1 to 2. So that's this vector here, and then this vector here is from 1 to 3, from 1 to 3. So this vector here is this vector. This vector here is this vector. This vector here is this vector. Now, if you select this point here, it would be bad because if you work out the determinant will give you the volume of the parallelepiped. But then to describe the plane, we would demand that the determinant of this equals 0. Because if you go back down here, if 3 vectors lie on the plane, then the volume or the determinant would be 0. So for us to describe this plane, we would demand that our general point be on this plane. Well, if it's on the plane, then it will have a volume of 0 or the determinant of 0. I hope you can follow that. Yeah. So the way we would describe this plane is that we demand the 3 vectors to have a volume of the determinant or the volume to be 0. Okay.